Hello everyone, my name is Chananthida Sopaphol, and today I'm going to present my self-learning topic, Serverless Agentic Workflow with AWS. This is my agenda. In this presentation, I will start with the history, how early AI assistants worked and why they were limited, and then I will explain what serverless computing is. The second one, I will explain what an agentic workflow means and how it differs from a regular chatbot. The third one, I will go through the core AWS service involved. Then in the second half, I will show you a real world example. In this slide, I choose a customer service bot so we can see the whole system working together. After that, I will compare AWS with the other two approaches, including Azure Computer Cloud and plain service-led without AI. And finally, I will discuss with the advantage and limitations of this approach. About the early AI assistant, before we can approach what agentic AI does, we need to understand what came before it and why it wasn't enough. This diagram comes from the Effectively Building AI Agent on the AWS Service-led blog, and it shows how a traditional AI assistant works. When a user sends a message, the user prompt on the left, the AI assistant assembled what we call a composite prompt. It combines three things: a simple prompt that tells the LM how to behave, the conversation history so it's remember the current section, and the last one is RAG context, which stands for retrieval augment generation. RAG is how the AI gets access to enterprise knowledge. It sends a query to an enterprise knowledge base. The database cylinder on the right retrieve relevant context and inject that into the prompt. All of that gets combined to one composite prompt that is sent to the LLM. The LLM then generates a response which go back to the user. This was a big improvement over the simple chatbot. The AI could now use up-to-date company data and remember what was said earlier in the conversation by using the right context. But this is the key limitation. The system is still passive. It can only answer the question as noted in the AWS documentation. Despite these improvements, traditional AI assistants still lack true autonomy. They couldn't reason through multi-step goals, make decisions on their own, or adjust workflow dynamically based on outcome. In other words, the work well for simple Q&A, but they couldn't plan, they couldn't take actions, or couldn't even handle complex real-world tasks. This is the problem that agentic AI will solve. This diagram that will explain how does the agentic AI system work differently. And once you understand this loop, everything else in this presentation will make sense. On the left, we see that we will input the context, the user message, and everything in agent knows going to this interaction that goes to the agentic system box in the center. Inside this system, there are four steps that repeat in a loop. The first one, the LLM does reasoning. It reads the input and thinks about what action to take next. The second one, as you can see, that it selects the tool, a specific function or the API it wants to call, such as the database query or some calculation. The third one is the execute that tool. When the tool run, connect to the outside world and return a result. For the first step, the system update the context. The tool result get fed back to the LLM and the new information. Then the loop start again. The LLM reason with the new information, selects another tool if needed, execute it, updates the context, and this continue until the LLM decide the goal has been achieved. At that point, it produces the final outcome at the right. This is called the agentic loop, and this is fundamental different from the traditional AI assistant that I just explained to you in the before slide. Instead of just assembling a prompt and calling the LLM once, the agent is talking the real action, calling the real APIs, querying real database, executing real code, and it keeps going until the job is done. Now that we understand what an agentic system is, let's look how AWS make this work in a serverless environment. What is the serverless? The agentic loop we saw is powerful, but to run it in the production, you need infrastructure, and this is where the serverless part come in. With the traditional server, as you can see in the slide, you will need a machine running 24 hours a day. Even when nobody is using it, you pay for it constantly, you manage the operating system, and with the traffic spike, you have to manually scale it up. This is both expensive and slow. With the serverless AWS Lambda, the approach is completely different. Your code runs only when it is triggered. For example, when a user sends a message that starts the agentic loop, the Lambda auto-scale instantly and you only pay per execution down to the millisecond. When the loop is idle, you pay nothing. This is a perfect match for agentic workflow, which are naturally unpredictable. Sometimes a user sends one message, sometimes 1,000. Serverless handle both cases automatically. With zero configuration, the key idea you only write the code and the AWS handle all of the infrastructure. For the AWS core service, now let's look at a specific AWS service that power a serverless agentic workflow. Because it's not just one service, it's a set of the service as you can see in the slide. AWS Lambda is the computing engine. It's run agent code whenever a message arrives, scale automatically and execute to call during the agentic loop. It's had 15-minute maximum runtime per invocation, which is an important limitation we will come back to later. First step in the function is the orchestrator. When an agentic workflow has multiple stages, like pre-processing, then running the agent, then post-processing, step function coordination, each step handle failure, retired, and can even push to wait for a human to approach something. For the Amazon Bedrock is the AI brain. It gives you agent across to the over 100 foundation models, including the Claude from the Anthropic, the Amazon, and Meta Llama, all this through a single managed API, no model infrastructure to run. For the agent core memory, solve the statelessness problem we saw earlier. It provides short-term memory with a session and a long-term memory across session, so the agent can remember user and preference over time. For the Bedrock guardrail automatically check every response before it reaches the user. It will blocking personal data leak, harmful content, and off-topic reply. And for the agent call observation give you a full trace of every reasoning step and every tool call. It's essential for debugging in production. Now we will talk about a real-world example. I choose the customer service bot that I learned in the deep learning AI course. Imagine a customer type, I ordered a blue mug 3 days ago. Order number 4821. No shipping confirmation yet, as you can see in the live example. Step 1, the message hit Amazon API gateway. The front door of the system, which immediately passes into the Lambda function. Step 2, the Lambda trigger function invoke the Amazon Bedrock agent. For the step 3, the LLM at the same reasoning step we saw in the agentic loop diagram. Read the message and decide I will need to look up this order first. This is the select two step from the diagram. For the step 4, the agent will call the action group, which is another Lambda function that query a DynamoDB database and return the real order status. This is execute to interaction with the outside world. Now the agent has the result. It reasons again, should it answer now or do something else first. It decides to also log a support ticket in the CRM, so the team is aware with the customer was worried. That is the second complete cycle of the agentic loop. And in the next step, before sending any reply, the Bedrock guardrail automatically scan the response. And in the last step, the customer get the final answer. As you can see in the live example, your book mark shipped tomorrow via FedEx. I will also log the ticket for your support team. The entire process had two calls: the real database lookup, automatic ticket locket, take about 2 to 5 seconds with no human agentic involved. Now let's zoom into on the agent call especially, because this is what makes the agent loop we discussed production ready to scale. The core problem the agent call solve is that running a real agentic system requires a lot of infrastructure that had nothing to do with the actual business logic. We will need session isolation, memory storage, automation, monitoring, security rule before the agent call. The developers had to build all of this from scratch. For the agent call, provide 6 module services, runtime each agent session inside the isolation micro VM, a lightweight one that virtual machine that is used up to 8 hours. This means one user agent cannot interfere with another's memory, which we will cover the detail on the next slide. Handle both short-term and the long-term knowledge retention. And this is the gateway that will turn your existing REST API and Lambda function into the tool that agent can discover and call using the MCP standard. Identically external the identically manage the OAuth token and API key, so agents can secure call the external service like the Salesforce on Slack. And this is the observability, give you a full step-by-step trace of every recent decision, and policy let you write rule into the CEDA language that block and authorize action deterministically outside the LLM, so that they cannot override by a clever prompt. One important point, agent call work with any agent framework and any foundation model. You don't have to rewrite existing code to use it. For the agent call memory that I talked about earlier, for the short-term memory and the long-term memory, remember in the traditional system, memory was limited to the current conversation history injection into the prompt. The moment a session ends, everything was forgotten. Agent call memory give agent 2 types of memory that work together. The short-term memory store the raw conversation turns within a single session. If the service restart on the server step anyway and come back, the agent reload the full conversation exactly where it left off. This lasts up to 8 hours, and you access it simply via session ID. No custom code needed. And for a long-term memory, it's more powerful. After a session ends, agent call automatically run a background process that read the conversation and extract meaningful insight, fact that preference, and the summary. These are stored as structured record and processed up to 365 days or 1 year. When the next session starts, the agent retrieve the most relevant memory using the semantic search. The example of the bottom of the slide make this concrete. In section 1, customer mentioned the preferred Nike shoe in size 10. Agent call quietly stored at the long-term memory in session 3 weeks later. The agent automatically remembers everything. For the AWS, compared to other serviceless approach, as you can see that the AWS Bedrock with the Lambda is what we've been discussed. Its standout feature in Agent Core, a fully managed 8-hour agent runtime with built-in memory. Its multiple model mean you can switch between Claude, the Llama, and others. The base fit it for the team already working in the AWS ecosystem. For the Azure AI Foundry, in Microsoft equivalent, it uses durable functional or orchestration and has a huge advantage with over 1,000 action connections through Azure Logic app. This is great for connecting to the enterprise system like a team, the SharePoint, and Dynamics memory management is not built in the same way too. The developers often need to build in themselves based for the Microsoft heavy organization. For the third one, we will talk about the Google Vertex AI with Cloud Run Take a more open, the developer-friendly approach. The agent development kit is open source and have been downloaded over 7 million times. It's used file store and BigQuery for memory, which work well for data-heavy application based for team already using Google ML and other platform. And the pain service less is the last one that we will discuss. Lambda with no AI layer. This is the simplest and cheapest option. There is no built-in LLM, no agent reasoning, just event drive function based for simple prediction, the workflow that don't need intelligence. In the conclusion, there is no single winner, but the right choice depends on where your team already live in the cloud. For the advantage and limitation, I will discuss both about the strength and the weakness of serverless agentic workflow on the AWS, because understanding the trade-off is just as important as knowing the benefit. On the advantage side, as you can see that you focus entirely on your agent logic. The system scale elastically is handle one user on a million with a zero configuration change. You pay per use, which make it very cost efficient for variable workload. Memory is built in through the agent core, eliminating hundreds of lines of custom code, and you call swap between the LLM without rewriting your agent. On the limitation side, the most important is the 15-minute Lambda execution limit. If your agent loop needed to run for a long time, say a complex result takes like 30 minutes task, you need to move to ECS instead of Lambda. Vendor lock-in also real once you build deeply in the AWS services. Migrating later is difficult. LLM interface cost can be unpredictable. It reasoning step and to call cost token, and this adds up quickly. Cold start can add small latency on the first invocation, and because of the LLM and non-deterministic, the same user might approach a slightly different workflow path each time, which makes automated testing harder than with the traditional software. Plan for this trade-off before you build, not after. Thank you for listening to my presentation for the serverless agentic AI workflow, the serverless agentic workflow with the AWS. If you have any question, you can leave the question under this video. Thank you.